Okay, here we are. It is, what's today's date? The 25th. And we're doing our last section in Chapter 5. Before that, though, I'll do some housekeeping. I moved your first midterm to February 1st. It's our first day back-to-back, face-to-face, unless we hear otherwise. And this Thursday, the 27th, I'm going to run the class like a workshop. So we'll all be on Zoom together. I got a little thing planned to get you ready for this first midterm, so you're not too shocked by it. Okay, so we're talking about arithmetic and geometric progressions, and here's the motivation for it. This whole chapter is based on this formula. Pretty much, this is the motor for all the other formulas that we've come up with. And this is what's called an arithmetic progression. And so you're adding bigger and bigger things up. And so here's our definition. And this is pure math, so an arithmetic progression is a sequence of numbers in which each term after the first term is obtained by adding a constant d to the previous term. So for example, if you look at the sequence 2, 5, 8, 11, 14, 5 is 2 plus 3, 8 is 5 plus 3, 11 is 8 plus 3, 14 is 11 plus 3. So here, d equals 3, and this is an arithmetic progression. First term 2. Okay. In general form, we use subscripts. So A1 would be 2, A2 would be 5, A3 would be 8, and then we have the nth term. So AN is called the nth term of the sequence. Okay, so we're going to show how to get a sum of these. So how do we find the sum of an arithmetic sequence? So our first term we're going to call A, and then our second term is going to be our first term plus D, which is A plus D. So our third term is going to be the second term plus D, which is this plus D, which is A plus 2D, all right? And our fourth term is going to be the third term plus D, which is this plus D, which is A plus 3D. Oops, spelled that wrong. A plus 3D. And so if you go down here to the nth term, you have the first term plus the nth minus 1 times d. All right, so just checking this, this is subscript math. So here's my n, so n equals 4, and the number in front of it's 1 less. Here, n equals 3, and the number in front of it is 2 less. All right, so if we have n here, the number in front of it is n minus 1d. Right. All right, so we can ask questions like, what is the 12th term in the sequence 2, 7, 12, 17, 22, like that, right? So in this case, D equals 5 because you add 5 to every term to get the next one, and N equals 12 because we're looking for the 12th term. So the 12th term is A, which is 2, plus N minus 1 times 5, which is 2 plus 11 times 5, and that number is 57. Okay. My 7s get sloppy on this pen. 57. Okay. So continuing on with sequences, let me go back to white. So we let the term S sub n be the sum of the first n terms. Okay? So just so we're clear, Sn is going to be A1 plus A2 plus A3 plus An. Okay? And what we want is a closed formula. For Sn. And this is a really cool trick. This is math trick 1459, okay? So Sn is what? It's A is the first term, A plus D is the second term, A plus 2D is the third term, and then the last term is A plus N minus 1 D. Okay. Right below this, I'm going to write it in reverse. So instead of going from A up to A plus N minus 1D, I'm going to start with the last term. So the second one is all the way down to plus A. Now here's the cool part. There are n terms in each of these sums. So I'm going to add these two together, just like we did in grade school. Okay. So on the left-hand side, I have 2Sn. Okay, so when I add, let's get this lined up right. When I add these first two terms together, I get 2A plus N minus 1D. When I add the next two terms together, I get 2A plus N minus 1D. All of them are the same, so I have now 2A plus N minus 1D. Right? And there are n of these. So we get this equation, 2Sn is equal to n times, oops, get my brackets right. Oops, back to pen, come on. 2A plus n minus 1d. All right, we just went from addition to multiplication, and now solving for Sn, we get n over 2 times 2A plus n minus 1d. And this is how you add up the first n terms of an arithmetic progression. Okay, and here's an amazing example from a famous mathematician named Euler. He did this when he was 8 years old. he was very hyperactive apparently, and his teacher got angry at him and said, go over to the corner and add up the first 100 numbers, thinking it would take him a couple hours. And he responded in less than a minute with the answer. And then he gave the guy a way to find it for any. So if you're adding up the first 100 numbers, you're looking at the sequence 1, 2, 3, 4, 5, all the way down to 100. And if you want to add all these up, here's what he did, which is exactly what this formula does. You take the first and the last number, you add them together, you get 101. You take the 2 and the 99, and you get 101, right? You take the 3 and the 98, and you get 101. Okay. Okay, and how many of them are there? Well, there's n. In this case, n is 100. Right? So the answer would be 100 times 101. Okay, so not 100. I got off track here. There's 50. Half of 100, the n over 2. So you have 50 times 101, and this is where it got really cool, because then he goes, well, 50 is 100 over 2, so that's our n over 2. And then if you have n, you can write it like that. So this is our formula, only applied to the first 100 numbers. Pretty amazing for an 8-year-old. All right. So that's an arithmetic progression. Each time you add a constant to the one before it. Okay, now we're going to look at the fun one. The funner one. It's a geometric progression. And this shows up everywhere in money. This definition is a little different. Each term in the sequence is a constant multiple of the previous term. So it's a little different. So here's an example. Here's a sequence: 1, 1/2, 1/4, 1/8, 1/16, right? To get from 1 to here, I multiply by a half. To get from 1 to here, from 1/2 to 1/4, I multiply by a half. To get from a 4th to an 8th, I multiply by a half. To get from an 8th to a 16th, I multiply by a half. So this is a geometric progression. Each term is a multiple of the previous term, and that's a constant multiple. In this case, the thing you multiply by is called the rate, and A is always the first term. Okay. So just like before, we want to find a closed formula for the nth term. Of a geometric progression. Okay, so with A1 equals A and R is the rate. So the first term is A. The second term is A times R. The third term is A times R squared. The fourth term is A times R cubed. And the nth term is A times R to the n minus 1. So that's how you find the nth term of this sequence. once you know what the first term is and what the rate is. Okay, so just like before, we're going to do some trickery. We want to find a formula, a closed form for the sum of the first n terms, and we'll call this Sn just like before. Okay, so this is super cool. So you take Sn is going to be the first term plus the second term plus the third term plus all the way down to the last term. All right, we're trying to get a formula for Sn. So here's the trick. We're going to multiply this line by r. And I get AR plus AR squared plus AR cubed plus AR to the n. Okay. Let me do this. I'm gonna rewrite this. Call this equation 1 and this equation 2. And what we're going to do is subtract them. We're going to subtract equation 1 minus equation 2. So we're subtracting up. So we have r s to the n minus s on the left here. And this is a really cool technique we use in mathematics all the time. So when you subtract, these guys go away, these guys go away, these guys go away, and this last term goes away, and that's all that's left is AR to the n minus A. Okay, and now we solve for Sn. So factor the Sn out of here. Okay, and then rewrite the left-hand side here. You get A times r to the n minus 1. And so Sn is equal to A to the Rn minus 1 over r minus 1. This is true only if r is not equal to 1. Okay. If r equals 1, it's just the sum of the constant terms, so it's Na. And there's the formula for the nth term of a geometric sequence. And note that this is in fact a geometric progression. And now we see the theory behind the motor of all of our equations from the term so far. So I'll write this here because I have it in front of me. Homework 3. This comes from section 5.4. Problems 9, 12, 16, 25, 26, and 34. This is due Monday before the midterm. And we're also going to add to this the workshop on Thursday. We'll work that through, and that'll be turned in as homework 3 as well. All right, I'll see you in a minute.